The first week of school, we learned how to categorize numbers. And we used this Venn diagram to learn it. Do y'all remember seeing this? It's been a long time, right? We learned that all numbers are, I can only hear one person. All numbers are real. They are either rational or can they be both of those at the same time? No. So y'all don't have to write this, but look. If I wanted to compare rational to irrational, they would have to look like that. The circles could never, if they look like this, that's saying that they can be the same at the same time. They cannot be the same at the same time. Does everybody see this line separating them? They are all what? But can they be both rational and irrational? No. So what's the difference? Your irrational numbers are pi and some square roots. Write that down. Your irrational numbers is pi. Every time pi is irrational, I promise you. And some square roots. How do you know if the square root is irrational? The only square roots that are rational are the ones that make whole numbers. So do y'all know? So if I look at my calculator, if I put in the square root of 25, do y'all know what it is? 5. That's rational because 5 is a whole number. Does that make sense to y'all? But if I put in the square root of 26, it's not a whole number. It is irrational. Does everybody understand? So these are your square roots that aren't whole numbers. For example, the square root of 26. It is irrational. So if you put in a square root in your calculator and it gives you a decimal, it is irrational. All other numbers are rational. Every other number in the world is rational. These are your fractions, your decimals. They are rational. Your integers, do we have to write down or is it already there? It's already there. And your whole numbers. These are your fractions, your decimals, your integers, and your whole numbers. Now, what y'all need to understand about this chart is that if a number is whole, like 5, it is also an integer. Is 5 an integer? Yes. It is also rational, and it's also real. So if it's in this circle, it's everything there. Make sense? Yes or no? Okay, so give me an example of a rational number that wouldn't fit an integer or whole. Any example. Just give me a number that would fit here. Yes? 3%. Perfect. I like that he said that percent. Why would 3% be rational? Because if I change it to a decimal, everybody look, it's what? 0.03. It would not be an integer. It would not be whole, but it would be rational. Can somebody else without a percent give me an example of a rational number? Look what I wrote right here. 4/5. 1/2. Yes. Those are your fractions. How about 25 cents? Where would that be? Where would 25 cents go? 25 cents. How do you write 25 cents? Okay, where would it go? Rational. So 25 cents would go here. An integer is a positive or negative counting number. So 1 and -1, 2 and -2, 3 and -3. What doesn't belong in integers is decimals. So if it has like 1.2, that's not an integer, that's just rational. So an example of an integer would be 5, but why is 5 here and not here? Because 5 is more specific to whole. So what could I put here for integer? Negative 5. Make sense? What about, let me ask you this, what about the negative square root of 25? Put it in your calculator. The negative square root of 25. What does that equal? Is that an integer? Yes. So I could write the negative square root of 25 here because I know that it's actually negative 5. So you do have to simplify these numbers before you can see where they actually go. Make sense? And then a whole number is an integer, but only the positive ones. A whole number is an integer, but only the positive ones. So like 1, 2, 3, 4, 5. How about the square root of 25? That's whole because what is the square root of 25? 5. What about a fraction that simplifies to a whole number, like 10 halves? What is 10 halves? 5. It's 10 divided by 2, right? Which is just 5. All of those equal 5, which is a whole number. Do you have any questions on that? Can we sit up, please? Can we sit up, please? All right, so how can these questions be asked on the STAR test? For one, they can ask you to interpret this chart, and one of the questions I have seen is the relationship between rational and irrational, and you just need to know that their circles can never overlap. Make sense? The other way is knowing that the big picture goes on the outside and the little picture goes on the inside. All right, the other way they can ask you is to place these numbers in the Venn diagram. So let's do that real quick. What is 24 simplify to? 5, yes? So where would 24ths best go on here? Whole number. So 24ths goes here. I'm done with that one. The square root of 35. Well, it's either going to be irrational or it's going to be whole. So you've got to put it in your calculator and see which one it is. So put in the square root of 35. Is that a whole number? Is that a whole number? No. So is it irrational? Yes. All square roots go to irrational unless they're whole numbers. The negative square root of 169. So it's either going to be irrational or it's going to go over here. We got to go put it into C. The negative square root of 169. What is that? So what kind of, is that whole? No, because it has a negative sign. Is it an integer? Yes. So the negative square root of 169 goes there. And where would negative 2.5 go? Please don't say integer. Because can we put decimals in integers? No. So what is it? It's just rational. It's just rational. All right, do y'all have a better understanding of that? Now let's look at another question. This is a question that I've seen on the STAR test every single year. And it says, which of the following would make the inequality true? Everybody look at this inequality. All this inequality is doing is saying this is from least to greatest, because this is the smallest, this is the middle, and that's the biggest. Do y'all see? So it's saying which number would fit right there between 2/3 and the square root of 6. So what would I do to these numbers to know? I heard one person. Turn them into? All right, let's go do it. Go do 2/3. Does everybody remember how to do 2/3? So we're going to put it in 2/3. Some of us are about to get phone calls home because we're not trying. Hit math, decimal, enter. Now, am I going to write that whole thing or am I going to make it look like money? So what would I cut it off at? If you put 66, you'll still get the same answer, but the correct way to round would be 67 cents. All right, go change the square root of 6 to a decimal. How much money is that worth? $2? and 45 cents. If you put 244, you'll get the same answer, so it's okay. So we want to find one of these that fits in the middle of 67 cents and $2.45. So we got to go change them all to, all right, 1/3. Go do it. Now I got to hit math, decimal, enter. How much money is 1/3? 33 cents. Does 33 cents fit between these two numbers? Not at all. It would fit over here. So that's out. Let's go to 25%. How do you change a percent to a decimal? Divided by 100. So 25 divided by 100 is 25 cents. Would 25 cents fit in the middle? Yes or no? Nope. All right, let's do 70%. 70 divided by 100. How much money is that? Don't say 7 pennies. 70 cents. Would that fit between 67 cents and $2.45? Yes, because it's bigger than 67 cents, but it's smaller than $2.45. So that's your answer. Do y'all have any questions on those? The last thing I want to tell you about these before we move on to scientific notation. Do not forget that with a negative sign, the more money you owe, the less money you have. Did everybody hear that? So real quick, right over here, I want you to put -5 and -7. Which one of these is greater? Let's talk about it. The more money I owe, the less money I have. Which one of these would you rather owe?
5.
Okay, why?
You would have.
Yeah, I would owe less and I would have more. Does that make sense? This is greater. This is the bigger number because the more money I owe, the less money I have. So think of it like money. The other way you could do it in your head is ask yourself, if these were positives, which one would be bigger?
7.
Because they're negatives, it's opposite. That's the best way you can answer it in your head, okay? If these were positives, 7 would be bigger. Because they're negatives, -5 is bigger. Because they're opposites. Any questions there? All right, the last thing we're going to review today is scientific notation. If it asks you to put a number in scientific notation, what are you going to do in your calculator? Mode, SCI. Everybody write that down. Write that down. You and I are about to step out and call your parents. So we can get it together or we're out. Okay, so you're going to go to mode, SCI, hit enter. Make sure normal's not flashing anymore. And then you simply type the number in. So 0.1, 2, 3, 4, 5, 6 zeros. And then 3, 5. Hit enter and that's your answer. But do I write the E?
You write times 10.
I write times 10. So 3.5 times 10 to the -7. Y'all remember this? Easy? Now, if it gives you a number in scientific and asks you to go back to standard, what do you have to do in your mode? Go back to normal. So everybody go back to normal mode. So go to mode, highlight normal, hit enter, and normal should be highlighted in black now. Then you simply go type this number in, so 2.34 times 10. And then does everybody remember the caret button right here to get to the exponent of -6? Did it work? No. Sometimes the calculator doesn't want to do it and you have to do it by hand. So let's refresh ourselves. This number tells us what? Move the decimal. How many places am I going to move it? 6 places. If it's positive, I move it to the right. If it's negative, I move it to the left. So all I'm going to do is write 2.34 and move this decimal 6 places to the left. Okay, so I'm going to go like this. That's 1 place, 2, 3, 4, 5, 6. My new decimal will go here. And what goes in those little baskets? So make sure the zeros go in the baskets. You wouldn't put it on the edge of the crib. It'll fall off. Put them in the basket. So my answer would be a decimal and then 1, 2, 3, 4, 5 zeros. 2, 3, 4. Could I put a 0 right here? Yes, it's just a placeholder. Is everybody good? You are going to go do 12 questions over what we just relearned. They are in the Google Classroom labeled 14-1. When you finish, you will bring them up to me for me to check, and this grade will go on next 6 weeks. So it is for a grade. I'm just not going to put it on this 6 weeks, okay? Come up and check with me when you're finished.